Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last video number 1071, I repaired this 12 volt 10 ampere power supply and I detected this optocoupler bad, one Zener diode short circuit, and while repairing we damaged this capacitor. And I received many comments from my viewers. First of all, I am thankful for everyone who is writing comments. And another thing, if my video is not good, it is your duty to dislike it. If the video is good, you can like if you want. But if the content is not original, if the content is bad, if it is misleading, it is your moral duty to dislike the video, so that this video must not be recommended to anyone. But if the video is good and you just dislike, don't write anything, that's not good. That's when I receive dislike on my video, that means the video is bad. When no one writes in the comments, that means might be this by mistake or this by due to his intentions. I don't care about that. But if the video is bad, please dislike the video. And always try to mention that this is wrong. I will welcome. First we will read the comments and then I will reply the questions. Nice to see the bad explode. Very entertaining. Yes, while repairing, I found this 680 microfarad 16 volt capacitor bad for test purpose. I did not install 680 microfarad. I installed 470 25 volt. The actual capacitor 680 microfarad 16 volt. It is for test purpose. Thank you for this good comment. Keep repairing SMPSs. This is nice to see all possible different problems. Output diode was also my first reaction. Yes, we will discuss. This comment in Czech language. Nice work. Even smoke effects today. Thank you. Yes, no problem. Original diode. Yes, we will see this diode. Without Zener diode working is not any issue. Yes, this is a repeated question for Zener diode. I cannot see the names. Spanish language. South America. Excellent video, thank you. From Peru. I am thankful for writing your comment. Then Ramzan Mubarak. Jazakallah khair. Jazakallah khair. Ramzan Mubarak alaykum wa alayna inshallah. Wish you happy Ramadan. Thank you, brother. Very nice information. Thank you. 194148. That is not a Zener. 194148 is a simple signal diode. I will make a separate video for this component. No problem. Perfect. Thank you. Without Zener diode, SMPS would working properly? Yes, we will discuss in detail after optocoupler connection feedback. Yes. We will discuss now. I have one question. What does a 4147 Zener diode do? Why does it work even without it? Yes, now we will discuss. Thank you for great video. But how did you know? You should check the Zener diode. Which were symptoms? Now I will draw the circuit of secondary side and I will explain why I checked this Zener. Very nice and scary video from Mr. Hisham. Thank you, brother. Very useful to see check optocoupler. How come the circuit is apparently working nice and smooth without Zener? Ramadan Mubarak from Morocco. Ramadan Mubarak alaykum wa alayna inshallah. Then Mr. Khalid Ataya from Lebanon. What did you say in Urdu? He gave me some timeline in my video. Yes, when I record my videos in two languages. First I say English and then same time I narrate with Urdu language. That is for my Pakistani and Indian viewers. So sometime in the editing some words remain in English videos, no problem. How to buy this solder machine? This solder machine, it is Weller WR3M rework station. That is not just only desolder machine. So WR3M, it's about $3,000. It's available with online suppliers, or you can purchase from your local suppliers. Schematic diagram where we can get, you can get the sample circuit from the data sheet. Download data sheet for that IC and then you can get a sample circuit. Then the same question, why you did not put the Zener diode back? Yes, I will explain. I wish Haseeb lived in USA. Thank you, brother. I am with you. You are with me. Thank you. Most welcome, brother. How to check IC without datasheet but only multimeter? Can you explain, sir, how? Really a very difficult question to be answered. Then no TL431? Yes, no TL431. In this power supply, TL431 was safe. Then German byte. I am thankful for sending super thanks, $2.99. Thank you for your valuable support. Let's discuss this circuit. The first question, Zener diode. The second question, how I detected Zener true test. The third question, TL431. These three questions. This time we will not work in primary side, we will discuss secondary side. This is transformer secondary winding. Then winding this end is reaching this side and this side. It is MBR 2000. MBRF 2000 CT, I think. Yes, it is MBRF 2000 CT. From the same AC line, there is one component here, that is this capacitor. With this capacitor there is a resistor and it is connected between this point to this point. It is RC snubber for fast recovery of this rectifier. This point is reaching to 1, 2, 3 points. 1, 2, 3, 4 points. One, two, 3 points. And second side, 1, 2, 3. These three are connected to common point, this winding. These are 3 capacitors, 1, 2, 3 capacitors. 2200 microfarad, 25 volt. Then the fourth connection here, that is this inductor. This one. And if we see this point covered, this covered, this covered, this done, this point already done, and one line is returning back here. Here is one resistor R28. That is exactly the same point that is here. It is 820 ohm current limiting resistor that is reaching to anode pin, pin 1 of this PC817 optocoupler. Pin number 2 is reaching to this point, that is TL431, pin number 3. Pin number 2 of TL431 is connected to ground. Coming to this point, there is class Y capacitor here. We don't need to check this capacitor. This will couple primary ground and secondary ground to remove the noises. Now this point, here is a resistor, 2.2 ohm resistor, this one, and it is connected to this fan connector. In this power supply there is no fan, and the second side of the connector is connected to this side. If we want to connect fan will be connected here. After this we have this capacitor and this capacitor, two capacitors in parallel. It is 680 microfarad, 16 volt. This damaged capacitor, 680 microfarad, 16 volt. Two capacitors in parallel. This is inductor end. From inductor there is a zener that is connected from this point and negative. Inductor, and between negative line there is a zener that is across this capacitor bank. So its number 1N4744A. Sorry, in my last video I discussed 1N4741. I'm sorry for that. It is 4744A. If we check its data sheet, 1N4744A data sheet, one N4744 15 volt Zener. It is 15 volt. This is the biggest question mark here. Why 15 volt Zener is here? Because when we are adjusting this power supply, it will adjust from 9 volt to 18 volt. From this positive line, if we see this component, that is this resistor, 10 kilo ohm resistor, from here 10K, with 10K there is another resistor. This is 10K, this is 2K. In series with 2K resistor there is this potentiometer. It is 102, 1 kilo ohm potentiometer. (2K) 1K, and 1K and 2K center point is coming to this TL431 pin number 1. And there is capacitor between pin 3 and pin 1, that is to prevent this circuit from fault switching. This is primary side. It is my opinion that this optocoupler damaged. Its damage is its material failure. If it is damaged due to this TL431, at that time these both components must damage. When we test it, input side IRED or LED is damaged. That means its failure is due to its internal structure, material whatsoever. When it failed, the power supply started to fluctuate. When it started to fluctuate, it will fluctuate between 10 volts to 18 volts, and continuous fluctuation will damage this Zener diode, because here it was using 194744 15 volt Zener. It is for safety purpose, because power supply is switching above than that limit and it receives continuous strikes, that Zener may damage. So that is reason in parallel, as a parallel regulator, as a safety component, this damaged. When it damaged, it was causing tick tick sound. That is due to this transformer, because when there is short circuit here, so that is the reason when I tested the MBR diode rectifier, it was giving continuity in both sides in circuit. Why? Because there was a short link here. If you connect in any direction, there must be a blocking voltage due to this Zener, but this Zener was damaged, so it was making short circuit. So that was the reason I removed this diode in my last video. I tested out of the circuit, it was giving good reading. Then I installed back again. After that, when it was powered on, I was touching the components. What is short circuit here? This Zener was heat up. Its temperature was increased. When any component is detected with over temperature, abnormal temperature, that is might be damaged. I detected it with over temperature condition. When I removed it, the circuit started fluctuation again. When it started fluctuation again, there are two capacitors in parallel, this one and this one. One capacitor, the same value capacitor, was weak. When it was weak, it exploded. It damaged. When it damaged, we replaced the capacitor. After replacing capacitor, still there was fluctuation. I removed this optocoupler. When removed optocoupler, the fluctuation was finished. Why? Because the feedback circuit started working normally. When it started working normally, the voltage was 12 volt. Below 15 volt, this Zener will not work. It will start working above its Zener voltage, that are 15 volt. We can say this power supply can provide maximum 15 volt. So that is the reason I did not install this Zener, because it was making short link. If this diode is present or not present, the power supply will work with this feedback. This is an extra layer of safety. So our questions: Zener diode, why this capacitor damaged? We discussed the reason, that when we removed this Zener, this PC817 was not working. The power supply started to fluctuate. That time the SMPS controller works in reboot mode from minimum duty cycle to maximum duty cycle, because that time its feedback is not reaching to IC. That time the IC will utilize maximum duty cycle, and that time that IC will reach in overload protection mode. That will cause to reboot the IC. When we fixed it, feedback network started to control the IC, 3842 IC here in this circuit. So power supply started working normally. Now if the voltage are 12 volt regulated with help of feedback network, that time if we don't install Zener, the power supply will work normal. But it is best to use Zener diode. TL431 safe? Yes, TL431 is safe, because its reason of damage is material failure. If we assume overcurrent condition, I think that is impossible, because 820 ohm resistor here is reference, because most of the time PC817 is working in class B. Its CTR, current transfer ratio is very low. It is not programmed in high current condition, so it works in safe limit, in linear conduction mode. This is my opinion. If you have any other opinion, I will request to write in the comments. If this video is informative for you, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.